Okay, so I just punched in the data and let me see. Okay, so I can just do something called um, AOV, which is going to do analysis of variance, and I'm going to store the output, the outputs into a variable called results. Okay, so I'm calling the command AOV for analysis of variance, and then I'm putting the results of AOV into a variable that I'm making up called result. Okay, and what AOV is I'm going to say explain weight, which we can see is just the vector of values that I have here. Okay, and I'm going to say explain weight by the groups. Okay, now the groups I just indicated is 1, 1, 1, 2, 2, 2, 2, 2, and 3, 3, 3. And what basically I'm going to say is that this 8 corresponds to group 1, 16 corresponds to group 1, 9 corresponds to group 1. This 9 corresponds to group 2, this 16 corresponds to group 2, this 21 corresponds to group 2, so on and so forth. And this last 6 corresponds to group 3. Okay, so it's matching them in that sort of way. Okay. When R sees the groups, because these are numbers, it's going to think it's a numeric relationship to a numeric relationship, okay? Which is not the case. It's a numeric variable, which is weight, which is related to a categorical variable, which is the groups, okay? So I have to let R know that I've got a categorical variable, and I'm going to say as.factor groups, okay? And then I hit enter, and boom, it's done. And okay, so I could say, okay, well, what was the result? And it tells me, it gives me this summary here, okay, which doesn't look all that interesting. So I'm going to ask, okay, well, give me a summary of the results, okay? And so here, it has produced the ANOVA table that we created ourselves, right? And you can see it omitted the total row because it doesn't even matter. So our degrees of freedom, because of as.factor groups, is 2, and our degrees of freedom for our residuals, or the inherent variation that exists, is 9. Sum of squares is right there. The mean squares, it calculates our F statistic, which is the ratio of this divided by this, and then it gives us a p-value. Okay, and this all matches up. Okay, and it did that very quickly, right? So that's nice. And we could do this for any data set that we get, and we can import things from Excel. So that's kind of neat. Okay. So anyway, you don't have to worry about this, but the command that you would use in R is AOV. All right. There's also an ANOVA command, which is also useful, but it's a little bit deeper. Okay. Let me. Okay, so here's an article that uses simple one-way ANOVA, all right? And this is called Age-Related Differences in Factors Associated with Smoking Initiation. Okay. So this was basically, you don't have to read the whole thing. You can. But basically, they wanted to know, what are some things that might affect the age at which someone starts to smoke? Okay, so that's a numeric variable, right? So they say, can we see, is there a relationship between the numeric variable when someone first starts smoking and other things. Okay, so so they went around, they surveyed a bunch of people who smoked, and they said, when did you start smoking? And then they asked them a bunch of other questions. And all of this explains all of that. So it talks about how they found people and how they did stuff. Okay, so here, these are the results. This is the results table. Okay, and so so here they have two groups. They surveyed a total of 1,447 people. Okay, and the average age at which people started smoking was 17 and a half years old, with a standard deviation of 3.8 years. So numeric variable. The first variable that they looked at was gender. Okay, and they said there's men and women, and 807 men, 640 women. The average age that the men started smoking was 16.8 years old. The average age that the women started smoking was 18.3 years old. Okay, and for this, because there's only two groups, you could do a t-test, and you get a p-value less than 0.001. Okay, what's the null hypothesis for this t-test? Yeah, that there's no difference between the mean age that men start smoking and the mean age where women start smoking. Okay, and under the null hypothesis, the probability that I would get a sample of 800 where the difference between them is this big is less than 0.001. Okay, so I got strong evidence that the mean age at which men and women start smoking is different. Okay, you could also do ANOVA. There's essentially when you do ANOVA for only two groups, the results will boil down to what you get in a t-test. Okay, they're related. The F distribution is built off of T distributions. It's weird, but it works out. Okay, but I mean t-tests are much easier, I think. Okay, here we have another variable. This is ethnicity. Okay, and they split it up into non-Hispanic white, Hispanic, African American. Okay, those are the three ethnicities that they found in this study, and they said, okay, what was the average age, or what was the age that you started smoking? Okay, and then they averaged those, and for the non-Hispanic white group, it was 17.3. For the Hispanic group, it was 17.5, and for the African American group, it was 18.4. Okay, and so here our null hypothesis is that the mean age for all three groups is the same, and the alternative is that at least one of the groups is different. Okay, and when they did that, they got a p-value of 0.001, which gives us strong evidence that at least one of the groups is different. Okay, but again, we don't know which group is the different one. Okay, now when you look at the numbers, it seems like 18.4 is different, more different from 17.5 than 17.3. Maybe, okay, but we don't really know because the difference caused by 17.3 may be magnified more because there was over 1,100 people in that group, okay, where there was only 200 people in this group, okay, so it's hard to say which group is the one that's different, or maybe it's both groups are different. We don't really know, okay. And so basically, every time you see one of these p-values, that's a different hypothesis test. So this p-value corresponds to the hypothesis test that these four groups have the same mean versus that they're different. At least one is different. And so this was the age at which someone started smoking based, is that related to how much education they attained, okay? So students who, or people who didn't finish high school, the age at which they started smoking, 16.5 on average, okay? Whereas those who finished high school started smoking at 17.9, those who had some college started at 17.2, and those who finished college started smoking at 17.8, okay? And it turns out that the p-value there is also very significant, giving indication that there is a relationship between these categories and the age at which someone started smoking. Okay, so with these summary statistics, we have the mean and we have the standard deviation and the number of students in each group. We can replicate the ANOVA test, our F ratios and things like that. We can replicate that ourselves and verify the p-values that these researchers got. Okay, so that's one of the exercises that you'll have in your homework. I did a demo for one of the categories or one of the tests. So that's that. Okay, this is I guess it's important to take a note at this point that just because you see an association, a relationship between one variable and another, doesn't mean that one causes another. Okay. It doesn't mean that finishing high school causes people to start smoking later. Okay. It doesn't mean that going to college is going to cause someone to start smoking. And here's questions. Did your father smoke or did your mother smoke? Okay. And there's strong evidence that there's a relationship between the two. But it doesn't mean that because one parent or the other parent smoke, that it causes the other person to smoke. Okay, that's not what it means. It just means there's some kind of relationship. Okay? And this is an observational study, right? We didn't say, all right, you guys are going to start smoking. So it's an observational study, so we can never make any kind of cause and effect relationships. Okay. So this was one table. This was based on the demographic information. Okay, and then over here, this table is asking, is the smoking habits, are they related to when someone started smoking? And so this is kind of interesting. So it's like, so here, if you smoke over a pack a day, so over 20 cigarettes, 20 or more cigarettes in a day, the age at which they started smoking, average is 17.2 versus the others 18.3. Okay, so again, we can't say it wouldn't even make sense to say smoking more caused someone to start smoking earlier, right? Okay, it seems much more that the opposite relationship might be true, even though, but it's not even safe to say that. Okay, it seems more likely to say starting to smoke early might be related or might cause someone to smoke more cigarettes in a day, but even that we cannot say. Okay, so there's all of this. Okay, so anyway, you can try that out. Simple exercise there. Okay, are there any questions?